everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Joel Chaiken, his brother. Our names are cut off. You can see it just for a second. Here we are. But the SAT question is so big today that we had to move things around so everybody, including us, can read it better. Otherwise, it would be much too tiny. Okay, everyone, let's go. This is a calculated question from a old SAT test. Okay, number of registered voters in U.S. in thousands. The table above shows the number of registered voters in that year in thousands in 4 geographic regions of this country and 5 age groups. Based on the table, if a registered voter who was 18 to 24 years old in 2000.
Wait. It's 18 to 44 years old.
What did I say?
24.
Okay, fine. So that was a typo.
It's really critical.
Yeah, but it wouldn't have. Okay, yes. 18 to 44. You're right. 18 to 44 years old in 2012. It shows at random which of the following is close to the probability the registered voters from the Midwest region. This is actually very similar, isn't it, to the problem we just did a few days ago with the marginal.
Yeah.
All right. Now wait. I have to now. Last time I made a mistake. So let me think this through. Let's see if I could redeem myself. Yeah, talking about the same year, so we don't have to worry about the year. Okay, everything is the year's the same. There's no conditioning on the year.
Okay, stop about the year.
Okay, Seth.
Relax.
Okay, calm down.
All right, move on to what's the juice of the problem.
I am getting to that. Okay. Now you want to. Which of the following? Which of the following is closest to probability? It's from the Midwest region. This is the Midwest region. I'll just sort of go like that a little bit. Maybe that'll help me. Now, based on the table, if a registered voter was registered between 18 and 44, that's these two things. So I'll go like that. Is chosen at random. So if one of these voters is chosen at random, if one of these voters was chosen at random, which of the following is close to the probability the voter was from the Midwest region? So isn't it, wow, so you really do need a calculator, but isn't it 14.7, I'm just writing it down, 14.7 plus 44 plus 47.9, which is the total of the Midwest region, and you divide that by...
No, it's the total of... That is the total of the age from 18 to 24 and 25 to 44.
That's right, exactly. Because
you said Midwest region.
You're right. So which of the following?
And the numerator.
Seth. Okay.
Yeah.
Seth. I'm redeeming myself. Okay. I think I'm doing it right. I may have said it wrong, but I wrote it right. Which of the following is close to probability that the registered voters in the Midwest region? So we want to put the Midwest region on top. And then we want to put all 18 to 44s on the bottom. Because that's the ratio. Right. The ratio of all the Midwest people divided by all 18 to 44. So that would be the answer, right?
That's right.
So now, because these numbers are pretty far away from each other, we don't have to waste time with our calculator typing every single number in, right? We don't. So let's just do it, okay? So we do 3.4. I may actually redeem myself on this problem. 3.4 plus 11.2, but I could still make a mistake. 14.6. Now we're going to do 14.7 plus 47.9. 62.6. So it looks like, it looks like it's going to be that one, but let's see. 14.6 divided by 62.6 is 23%. So it's that one.
Right. Sounds good.
So yeah. So this really was a conditional one, right? Where we really did have to pay attention to the condition.
This is called a conditional probability question. However, you could do this question simply by understanding what the question asks. And then if you understand what the question asks, you could appreciate and learn that what is asking? It is asking for a number that is called a conditional probability.
Okay.
But you don't have to know that this is called conditional probability to simply answer the question by following your nose and looking at what it's asking for.
Exactly. That's exactly right. Just use
Yeah.
total common sense. Total common
Yeah.
sense
Yeah.
will give you the answer. Right. Yeah. And the reason why I go so slow on these problems is because I never took probability in school as my weak point. But I know that. I know that
Yeah.
about myself. So because of that, when I see a probability question, I'm a little more careful because I'm not that great at it. And that's what you should do too. If you have a subject in math, an SAT thing that you're not that great at, when you hit that question, be a little bit more careful. And study those questions a little bit better. So, anything else to say? I said a lot of stuff wrong, but I wrote a lot of stuff right.
Yeah.
Yeah,
but the trick is, it's easy to, if you read, when you look at numbers, look at a number, look at it carefully, and whenever you see a number, unlike a word, you see a number, slow down and think that is a number, and it is 44.
Right. Yeah, well, that wasn't my mistake. My mistake was I said things in the numerator and the denominator the wrong way.
Yeah.
I hope people understood that the little trick here about you don't have to write down every single number, and you can put these in thousands, 14.7 thousand and 47.9 thousand. Makes it a little easier. You probably could have even just done 3 plus 11 divided by 14 plus 48. That would have done it also, right? 3 plus 11.
Oh yeah. That would work because the choices differ a lot more than in one digit out of two.
Exactly. That's exactly right.
And here, here they give the numbers to one digit out of four accuracy, and they're asking for a level of accuracy that is like one digit, single digit.
Yeah.
1, 2, 1, 2 or 3, 4, and 7 or 8. And so this ought to give a very close estimate as well.
Right. Yeah.
Because here you're only using 2 digits.
Yep. Yeah.
Yeah. So here you get 14 over 62.
Yeah, right. Yeah, 14 divided by 62 is 0.22 and a half. So yeah.
Yeah.
Okay, so I think that's it, right? I guess today is Throwback Thursday.
Okay, Throwback Thursday time.
Here we go. Drum roll, Throwback Thursday. Already looked to find a really hard-looking problem, a problem that you would probably not see on the modern SAT. So here it is. I looked at this thing. It was always the case. I never do the problems ahead of time. And this one, I'm not even sure if I'll be able to do in any efficient time. So this may have to be a Seth thing. Feed the Seth. That's what we do. When we do the tough math questions, we feed the Seth.
Nice.
Okay, so now maybe we could make this a little smaller, give ourselves a little more space.
Okay, there's a common heading for the problem.
Okay, so now let's read this thing. Notice you never see these types of questions on the modern SAT. Okay, you answer A if quantity column A is greater. You answer B if column B is greater. If the two are the same, you do C. And if you can't tell the relationship, you do D. So, I got it. Everybody got the idea what you have to say. A, B, C, or D. C is equal. D, you can't tell. Here we go. This is the question. R plus P times 25 is Rx plus PY for all values of RB. Even Seth, when you feed the Seth and he says, wow, you know it's not going
Holy smokes.
Holy smokes is right. Look, can I just do this? Can I just distribute just because I feel like?
Oh, that looks good.
Oh, wow. Wait a second. That may actually help, right? Wait,
Yeah.
let's line everything up. R plus 25p is equal to x times r plus y times p. Oh, I lined everything up nicely, didn't
Yeah.
I? Right? The
Yeah.
r's, the p's. So now let's see if we can tell something about this, right? So
Okay.
we want to know something about this, right?
Well, let's follow our noses and see what happens.
Agreed. Let's follow our noses.
It is given that this equation is true for every value of r and p.
Right.
Now, expression A is a special case. A is a special case. This is a special case of what's below when r equals 1 and p equals 1. So if we believe what the we let us follow our nose and believe what the given is said, apply what the given is said for particular values r equals 1 and p equals 1. This gives us x plus y equals 25 times 1 plus 25 times 1. So we could conclude from this being true that x plus y is 25 plus 25, which is 50. And so I would say that the answer is that, A equals B, because the thing in column A is x plus y. We've demonstrated from the given that x plus y equals 50 and b equals 50.
Yeah, but
so they're equal.
But that's only for the special case where r is.
What I'm doing is following the logic. Okay. You have to read it in logic. So the logic of the statement is it says what it says. For all values of r and p,
right,
we have equality here. That means you could pick any r you want and any p you want, and this will be equal. Okay? So I pick r equals 1 and p equals 1.
Yeah, but maybe you were lucky. How about why don't you make r be 2?
Well, let's see. I'm not. What I'm doing is not worrying about how consistent this is. So let's see. What does this equation say? What does this equation say when r equals 0 and p equals 1? Well, when r equals 0 and p equals 1, we get 0 plus 1 times 25 equals y. So this tells us that y equals 25. Now, if we take r equals 1 and p equals 0, r is 1, p is 0, multiplied by 25, and we are told that's equal to 1 times x plus 0 times y. That tells us that x equals 25. So by applying the rule that they give us here, this tells us that x must be 25 and y must be 25. And therefore, x plus y must be 50.
Oh. Well, I see it. Wait, but
maybe... Yeah, so what I did was I reached the conclusion. I figured out how to demonstrate the conclusion that these are equal in 2 different ways. The first way is maybe it doesn't clearly tell you why it's true. Well, it doesn't give you much intuition. All I did was follow my nose from what is stated as a hypothesis. I plugged in R equals 1 and P equals 1 in order to get X plus Y. And this formula told me that X plus Y is 2 times 25. So that's first method. Second method, I found what X was, and then I found what Y was, and then I added what I found. I found by applying this fact to R equals 1 and P equals 0. I found that X equals 25, and applying it for R equals 0 and P equals 1, Y equals 25. Okay?
Wait, so Seth, can I do it like this? Can I just look at this equation and see that in order for this to happen, X has to be 25?
Yeah.
And Y
yes.
has to be 25?
Yes,
so
you can do that too.
X plus
yeah,
Y.
So this is saying
50.
for arbitrary, or the only way this could be true for arbitrary R and P is for of X to be 25 and Y to be 25. Yeah.
Oh, that's the only way this can be true. The X has to be 25 and Y has to be 25.
Yeah.
Okay. Weird question, right?
It's tricky. Yeah. It's
question.
So it's a question that could lead you into a situation that you may never have seen in school.
Right. Yeah.
But it succumbs. The problem is solved. The question is answerable by careful, step-by-step logical thinking.
Yeah.
Okay.
Let me be honest, I haven't followed Seth's two answers as well as, and no, I really haven't followed how Seth did it, but I sort of see how I did it. But I sort of understand what Seth did. But he set an R to be 1 and a P to be 1, and he played with it. He set an R to be 0 and a P to be 1, and vice versa. And he realized in both cases that X plus Y have to always equal 50.
Yeah.
Yeah. Okay.
So by setting R to 1 and P equals 0, and then R equals 0 and P equals 1, you get two pieces of information that are stronger than the piece of information that X plus Y equals 20 equals 50. It tells you by those two choices of R and P, those two choices for the pair RP, 1, 0, the other choice 0, 1, you could figure out that exactly what X is. And then figure out exactly what Y is.
What would just let's play with it for a second. What would happen if you set it random, like weird numbers, like R is 2 and P is 5?
Well, do it. See what happens.
If R is 2,
then what you're going to get is you'll get 2 times 25 plus 5 times 25.
Yeah, but you have 2x plus 5y. This is equal to 2x plus 5y. Oh, I said R was 2, so I put a 2 there, and I put a 5 here. So 2x plus 5y. Oh, yeah, you could factor out. Right, you could factor out the 2 and the 5. The 2. You could factor out the 25 here. No, can't you? Yeah, factor out the 25 and you get 2 plus 5. Wait, I'm doing it. Oh, wait, this is equal to 50. God. Oh, I see. Yeah. If you line these up, this 2 means that this 2 means that x is 25,
Mm.
and this 5 means that y is 25. So x plus y is always 50, right?
Yeah, yeah.
Wait, so that means x is always 25 and y is always 25.
Yeah, yeah.
Right.
That's right.
Right.
The only way for this equation to be true for all R and P is for x to be 25 and y to be 25.
Right, okay. I see that if I go my route, you could really sort of go crazy with all the numbers.
Yeah,
This
yeah,
is
yeah.
50. This is 50 plus 125, which is 175.
Yeah, yeah.
And this
Yeah.
is 2x
Okay.
plus 5.
Yeah, maybe easier to see what's going on from algebra by
Let me erase all my
interchanging
stuff.
the multiplications. R plus P. Can people see what I'm writing?
Now, let me just erase all my red garbage.
I'm writing on the top.
Okay. Oh, no, you can't. Wait, hold on. Now people could see what you're doing.
Okay, so I'm writing on the top. I wrote R plus P, quantity times 25, equals R times 25 plus P times 25,
Right?
equals, now Rx plus Py, I'm going to flip them around and write XR. No, what am I doing? No. Wait a minute. Oh, you flipped it around.
Yeah.
You flipped it around.
Yeah. The green.
If we don't flip it around.
Yeah.
We don't flip it around. And just write it, just multiply out. R plus P times 25 equals R times 25 plus P 25. And then write this, Rx plus Px.
No, PY. PY.
I'm sorry. Yeah, thank you. Notice the R here. Oh, sorry, silly pen. The R, there's an R here, which matches the R here.
Yeah, that's what I said down here.
And there's a P here that matches the P here. Yeah. And we see that sort of pattern matching.
Right. So
whatever multiplies R is 20 on this side is 25, so X has to be 25.
Yeah.
And whatever multiplies P is the Y, and that's so Y is 25.
Yeah, that's what I said here, Seth.
Right. Yeah, so we got a little, so we didn't see that right away. We didn't see that right away because what you did was flip. You put the 25 on the other side.
No, but I tried to see it. I tried to line them up.
Yeah, I know. What you did was use you followed the habit of putting the constant on the left.
Oh, I see.
And that led to not immediately seeing the pattern that on the right, X is a coefficient of R and 25 is a coefficient of R.
Right.
So what they did was use R and P in roles that are traditionally, they used R and P for letters that stand for variables. And they used X and Y for constants, which conflicts with the arbitrary tradition that X and Y are used as variables.
Right.
So in this problem, the variables are R and P. And as a result of the properties of an equation, one equation and two unknowns, where the variables, the unknowns are R and P, you could derive what the constants are. And the unknown constants are X and Y.
Wow. look at that. That's a really great insight, Seth. Yeah.
Yeah,
That's
yeah.
why
So
you bring, yeah.
yeah. So yeah, it's you know, it's so if you're too fluent with algebra, if you do algebra so automatically you don't think about it, and you see, oh, X and Y, treat them as variables. Well, and treat them as variables in a relation. What's really happening is R and P are variables that participate in the relation that the left-hand side equals the right-hand side, and that you want to find the values of the unknowns X and Y that makes that relation always true.
So, Seth, let's finish with the final thing, which I think would be fun to do. Can you, being Seth, can you write this question where X and Y are normally the variable, where really are the variables, and R and P are the constants? And let's see what the question would look like.
I think, just interchange X with R.
Yeah.
Let's see.
So go ahead, rewrite.
Interchange X with R and interchange Y with P.
So okay,
what that entails, changing. It entails. I'm not going to actually do the change. I'm going to mark what needs to be changed. It entails changing this equation,
right? So let me
changing these two things, and changing X plus Y.
I'll do it. X plus Y plus 25 is equal to X R plus YP for all values of X and Y. Is that right?
Yeah.
All values of X and Y. So is that easier to understand? And they want to know P and Q compared to 50.
Yeah. And then like you did before, I'll make a thicker line. What you did before was rewrite the top.
Yeah, so
you rewrote the top as X times 25 plus Y times 25.
Yeah, my Zyboard froze. I'll do it in a second.
Equals X times R plus Y times P.
Okay. Okay. Yeah. Wait 1 second. Okay, here we go. So we have. Oh, you have it up there, Seth. So, wait. So you have it there. Okay. So let's see. Equals X times R plus Y times P. Now we're saying P and Q.
And now we're saying for all R and P.
P and R.
Yeah.
For all XY. For all XY, what is P plus R?
Yeah. What is R and what's P? Yeah.
What is R and what's P?
Yeah. So again, the same argument applies to figure out the unknown. They figure out with the constant R, what R must be. X being a variable and Y being a variable, you could pick any value for it.
Right.
Pick X equals 1 and Y equals 0, and you get R equals 25. And then pick Y equals 1 and X equals 0, and you get P equals 25.
Oh, right. Yeah. So R plus P always has to equal 50.
Yeah.
You see it here. Yeah.
Okay, good. Okay, but again, I think what led me to answering the question, figuring out the problem at the beginning was simply reading the statement and applying the statement using logic, taking advantage of what the statement said.
Yeah.
And I really, as you do math, you have to, when a statement is given, what is given? The given is that equation, R plus P quantity times 25 equals Rx plus Py. That's equal for all values of R and P. You really have to take that seriously. Okay? And
Yeah.
that and now when you take that seriously, it means that if you could pick any value of R and any value of P that you want.
Yeah.
And the math, the given will tell you something about the data.
Hmm.
And then I noticed that I could get an expression I could get information about the X plus Y in the box. I could get information by picking R is 1 and P is 1. So that's what I did.
Yeah, but
I plugged in R equals 1, P equals 1 in the left-hand side, and bingo, 50 came out.
yeah, but don't you honestly have to
That
check
is how I did it.
Yeah, but Seth, but isn't it possible that there could have been a coincidence that R was 1?
Maybe there was a coincidence. In fact, I did not realize that what we're looking at is characterizes the function of P and R that the expression represented.
But
I didn't realize the situation that we went into describing later. What I did was apply the logic of something is true with variables for all values of two of the variables.
Yeah.
I just used it because it was a given in the problem. And I took advantage of it because I knew from what they told us that I could put in any values I wanted.
Right.
And a value of 1 and 1 is a choice that's covered by for all.
Yeah. So Seth,
and I did that, and bingo, the answer came out.
Yeah, but then just to
be
sure,
that's how I did it,
Seth. But just to be sure, you have to check another case because it's possible P is 1, R is 1.
It's possible, yeah. So it's possible. It's possible that it's possible, but further analysis rules out crazy stuff that you might think is possible.
No, so then you just draw R as 0 and P as 1. You just try another case.
And then I wanted to see, investigate. I was curious about, hey, this seems a bit crazy. So what's possible? So what I did was investigate. What if I pick other values for R and P?
Yeah.
What other information do I get? And that led me to realize that the information in the problem actually tells you more than what X plus Y is. The information in the problem tells you what X is separately from what Y is.
Right. Now, of course, when you're doing the SAT, you're not doing this analysis, right? You're just getting the answer and moving on.
Yeah. If I were doing this in an exam, in an exam situation, I hope I would use the same logic. And then when I realized that picking those picks for R and P would tell me right away what X plus Y was, then I'd answer it and be done with it.
Yeah. Okay. Honestly, I'm not sure how I would have done this. Seth took the ball and did it before I had a chance to do it. But as Seth was doing it, I did notice this analysis.
Yeah.
But
I must remark that in my experience with students, applying facts like the fact that the problem starts with, a fact that says for all P and R something is true, that is something many of my students had difficulty with.
Yeah. So would it have said for any value of P and R? Would that have
No, it doesn't matter. Doesn't matter.
Hmm.
It's the concept that seems to be
right. So
not all natural, not really immediately natural for many people to think.
So essentially what you're saying is if you see a problem and it says for all P and R, you have liberty to pick any P and any R you want, and you would choose the ones that are most convenient at first.
That's right, yeah.
Right? That's essentially what Seth's saying. Yeah, but if it was me, I would use two cases because you could pick a P and R that could be a special case, which could make it true only for those P and Rs. So you really should check at least two examples of P and R. When it says for all P and R, if you're just going to choose,
Yeah. So what they could have done is pose a different question, same hypothesis, but the question is, what are X and Y? And then they could say, well, X equals 25, Y equals 25, X equals 50, Y equals 0. And they could say X and Y are undetermined.
Yeah.
Or they could say, what's possible? So what this problem is doing is asking, given that for all statements, what is possible? Is it possible for X plus Y to be greater than 50? And is it possible for X plus Y to be less than 50? And if it is possible, is it always true? Is it possible for X plus Y to be 50? And also possible that X plus Y is greater than 50? If that happens, you'd have to answer, you cannot tell.
Right.
You can't, this category of question asks for, there are four choices. What could you send? There we are. So choice A, B, C, D is the last choice, the D choice. The relationship cannot be determined.
Yeah. Well, maybe we'll hit one of those. That'll be interesting.
Maybe. Right.
Okay, so I think that finishes the Thursday, Throwback Thursday, back to a test that was given about in the early 2000s, maybe late 1990s. Okay, everyone, thanks for listening on this. We're going to see that we really are getting away from what I first said about we're going to help you analyze how to do math SAT questions. Turns out on this one, we went a little bit too far and we overanalyzed the question. So what Seth talked about, you wouldn't actually do on the test. But what we do is it's after commentary about analyzing the question, understanding what they were really getting at. So I hope everyone enjoyed at least the first part. And the second part was, Throwback Thursday. Okay, everyone, have a great day. And if you please send us comments to, put comments on the YouTube channel, and then please send us your SAT math questions at satmathquestionoftheday@gmail.com. Okay, everyone, have a great Thursday. Bye.